Alright, so in this video we're going to be looking at this set uh, of polynomials of degree 4 or less, and we're going to try to determine whether or not this polynomial set is linearly independent. To find that out, we're looking at a linear combination of these, and so I find it personally more easier, I said that. I find it easier to write it out in kind of like a matrix form, recognizing that each of the constants, the linear terms, the square terms, the cubic terms, and the quartic terms, were going to be multiplied by the corresponding constant. So you're going to have c1 times the original times the first polynomial, which was x to the fourth minus 4x cubed minus 3x squared plus 2x plus 3. And that's where the 3 comes from. So in each of those, I was just looking at the linear terms since they're all lined up and multiplying each of those by the c1 term, because they're all going to get a c1 term, a c2 term, a c3 term. So each of the individual values gets an individual constant term multiplied by it. Okay, and so setting up this sort of like an array kind of helps me for bookkeeping purposes to understand where each one's going. And each of these equations individually are equal to 0 because the polynomial, or the 0 polynomial, has to match coefficients in every entry is equal to 0. So plugging these in to form this linear system, okay, we get the coefficient matrix times the undetermined coefficients, that's what we're looking for, times is equal to the 0 matrix. Okay, all right, so we put this into GeoGebra and we found, all right, so after entering in the matrix, what we found is when we do reduced row echelon form, you can see here we have a pivot and a pivot and a pivot. However, in column 4, V4 is written as a linear combination of V1 and V2. And then we have another pivot for V5, V6, but V7 is a very big linear combination of every other vector except for V4. So these two sets are not linear and infinite. And I'll write this out one more time. After seeing the results from GeoGebra, writing this out, so it does show then that the matrix from GeoGebra showed us that V4 is an easier linear combination. It can be written as the opposite of 2V1 plus V2. V7 is the corresponding mix match of all of the other samplings. So I don't know about you, but those fractions would be obvious combinations. So you'll see that all of the vectors except for V4 show up as a linear combination of this final vector V7. So it's a little bit of all of the vectors. Okay, so it is definitely not linearly independent, and it in fact has two vectors that are linearly dependent, which are shown here. Okay, I hope that was helpful, and I'll see you in the next video.